you?
Good. So what are we going to do tonight?
Verifying.
Okay, I just spent an hour verifying trig equations. Probably the same ones you're doing, I'll bet.
Probably.
I think so. I think you're going to the same school as this guy. Do these look familiar?
Yep.
Okay, good. I've just done all of them. So, he had 3 sheets. Is this your first one?
I only have 2, and that is one of them.
That is one of them? What, is this your first one, maybe?
Yes, that is my first one.
Okay, let's start here. I'll tell you in advance, one of these I couldn't do, but I can do all of these. All right.
I have, which ones do I have done? I have a couple of them done, and then most of them, though, are just not.
Okay, which ones do you have done? We won't do them again.
I have number 2 done and number 1 done.
Okay. Let's start with 3. Let's start with 3. Now, you and I haven't done verifying yet before, have we?
Nope.
Okay. Well, verifying is all about knowing your trig identities and some unusual algebra techniques.
Yes.
Now, if you can get both sides of your equation all in the same trig function, that's usually a good idea to do. Okay? So, I got tan over here, I got tan there, and I can turn that into tan. So let's do that. So
oh wait, for which one, I guess? Maybe we don't have the same ones. For number 3?
Yeah.
Nope, mine's different.
Oh, is it? Okay. Why don't you read me?
The same title.
Read me yours. Okay.
Okay.
What is your number?
Secant squared theta plus cosecant squared theta equals secant squared theta times cosecant squared theta.
This is your number 3?
Yeah.
That's not it. Hold it. Is that it? Yeah. That's my number 3 on this sheet. All right. We'll do this sheet here. Let me close out that one. All right. So, just did this. I should be able to remember how to do it. Well, I can turn secant squared into tangent squared plus 1, but that doesn't help because there's no other tangent squareds anywhere. I can turn cosecant into cotangent squared plus 1. That also doesn't help. So this is actually the perfect problem to turn everything into sines and cosines. So let's do the left side only, turning it into sines and cosines, and see what happens. So what does this term become?
That becomes 1 over cosine squared theta plus 1 over sine squared theta is equal to secant.
Now add those two together algebraically.
We need to find a common denominator.
Which is?
Cosecant squared times sine squared.
Cosine squared times sine squared.
Sorry, yeah.
What's the top? Numerator becomes?
2.
No, becomes sine squared theta
Oh, yeah.
plus cosine squared theta. In other words, when you add 1 over x plus 1 over y, you get x plus y over x times y. That's all you're doing here. In other words, you still use the same rules of adding fractions. Now, what's the top?
Now, 1.
So it's 1 over cosine squared sine squared. And we're trying to prove that it's equal to secant squared cosecant squared. Well, what's that equal to?
That is equal to secant squared times cosecant squared.
Times cosine squared.
Sorry, yeah.
No, you're right. Times cosecant. What am I thinking? Cosecant. Sorry, my mistake. But it's the identity. In other words, we've done it. So I want to try to lend advice on how to do these. It's not always easy because some of them, it's quite an art to do it. It's not only knowing your trig identities, but it's knowing the right technique algebraically to use. Now, this one, what's the right side say over here? It's 1 minus 4 cosine of x all over 1 minus cosine x?
Yeah, I started this one, but I got stuck.
Okay. Now, it looks like the left is the more complicated side, but it really isn't. The right is the more complicated side. Why? Because we got a fraction and the denominator is a binomial term. It's not a single term. So it's really better to operate on the right in this case. Here's the thing you want to look for. Whenever you see that, 1 minus cosine or 1 minus sine, either one, you usually want to multiply this by the conjugate. Almost always. I've seen one problem where that wasn't the way to do it, but the reason multiplying by the conjugate works so well is because it always turns the bottom into 1 minus cosine squared, which can be substituted with sine squared.
Okay.
So there's the conjugate, right? The denominator is the conjugate of this, and we have to multiply by the numerator also because we can only multiply by 1. Well,
yeah.
The denominator turns into 1 minus cosine squared, which is sine squared. So now this numerator times that must be this. And you'll see that it is. If I FOIL these two together, I get 1 minus 3 cosine x minus 4 cosine squared x. And I've turned the right side into the left side. In one step, by merely multiplying the right side by the conjugate, divided by the conjugate. And that's a pretty common step, but usually only for 1 minus cosine or 1 minus sine. And the reason is that we get to replace two terms with one term after we do it. Okay?
Okay.
All right, the other thing you need in verifying trig identities is sum of squares, difference of squares, difference of cubes, and sum of cubes. This looks like the sum of cubes.
Yeah.
How does that factor?
I think I got that. Would it be sine minus cosine plus b?
How does a cubed plus b cubed factor?
Into a minus, or the cube root of a minus the cube root of b, and then sine, or a squared plus ab plus b squared.
Okay, use that to factor this.
Okay, so you get sine minus cosine.
Sine plus cosine, sine, because it's, excuse me, this is actually plus and this is minus. Always make the linear factor the same sign, and make the quadratic factor have the opposite sign in the middle. Okay, so this becomes sine squared minus sine cosine plus cosine squared. Okay? Now, what can I do with that term right there?
Wait, which term?
Over here.
Oh, okay, sorry. Lost track of the
I can reduce that.
Yeah.
Into?
So it would be, wait, why is it squared?
That's a good question. Oh no, it's supposed to be squared.
Wait, no, never mind. It's just a scribble, I think. Okay, never mind. Okay, so you would have to do, can you pull out a sine? No, you can't pull out a sine and a cosine.
Well, sine plus cosine is 1. So is this not equal to sine plus cosine times 1 minus sine cosine?
How did you get that?
Well, and I don't think that's right. Oh, I know what. Yeah, it is right. Remember that we were just working with, okay, first of all, how did I get this? See that sine squared and that cosine squared? That's equal to 1. So this term turned into this term.
But how did you, factor it, or?
No. I replaced the sine squared plus the cosine squared with 1.
Yeah.
So now I have 1 minus sine cosine times sine plus cosine. But remember, on the left side over here, we have a sine A plus cosine A in the denominator. So I'm going to divide by sine A plus cosine A, canceling out that and that, leaving me with that, which is what I'm trying to prove. In other words, after you use the sum of cubes to factor that, the linear factor cancels with the bottom. And you're left with just the quadratic factor, this factor right here. And that factor turns into 1 minus sine cosine. Always look to be reducing terms. In other words, I have 2 terms here, and I can turn them into one number. Always do that. What's this equal to? Oh, excuse me, hold on. Excuse me, I meant to say secant squared minus tan squared. This is where you really have to know your identities, your Pythagorean identities.
Yeah, I have trouble identifying where they are sometimes.
Okay, let's go through the 3 of them.
I have them memorized, but then when they're in in that last one.
Well, the problem is that you rarely see it in this format. You almost always see it in the format that's been altered. In other words, we rarely see sine squared plus cosine squared. What we usually see is 1 minus cosine squared, or 1 minus sine squared. So know what that is. That's sine squared. Know what that is. That's cosine squared. Based on that identity. Now, the second big identity that you have memorized is this one. And that's all you have to memorize, because the third one is the second one only using the cofunctions. In other words, the cofunction of tan is cotan, and the cofunction of secant is cosecant. So we don't actually have to memorize that one. We can always figure it out. It's the cofunctions of the second one. So once again, what is secant squared minus tan squared equal to?
Negative 1, 1.
Positive 1.
Yeah.
And cosecant squared minus cotangent squared is also equal to 1.
Mm-hmm.
So I've definitely seen problems where you have to do difference and sum of cubes. Now, number 6. I could not get number 6 to work, but that's because he cut off the right side, and I'm convinced he didn't read it right to me. But maybe, what's your say? What's your say?
Cosecant, suppose 6, oh yeah, you got that. And then it's equal to 1 plus 3 cosecant squared x times cotangent squared x.
God, that's what he said. I could not get this to work. All right, I'll try to do it again. I may have just made a math error the first time. Or else this is a typo, and this is not an identity. And I've never seen them do that. I've never seen them give you an identity that isn't one. And in fact, the worst thing, the most torturous thing you can do to a student is to give them a multiple choice trig identity. Because how do you do multiple choice? You're not taught to do multiple choice. You never are given ones that are not identities. What is that? How are we going to... In other words, we already have everything in cosecant and cotangent. So we should be able to algebraically manipulate this without using any identities at all and turn this left side into the right side. So if I gave you x to the 6th minus y to the 6th, can you factor that?
Yes, because...
As difference of squares or difference of cubes?
Difference of...
Either one.
Because it's 6, right?
Well, yeah, notice that that is x cubed minus y cubed times x cubed plus y cubed. Right? In other words, I can use difference of squares on that. Only the square root of x to the 6th is x to the cube.
Yeah.
Okay? Or I can treat this as that's the difference of cubes. And I'm going to narrow it down to x squared minus y squared times x to the 4th, and so forth and so on. But the first time I went through this, I'm pretty sure that you want to start out by doing difference of squares. And then go from that to difference of cubes. So, what is this factored as difference of squares?
Okay.
Fill in the rest for me.
You have cosecant squared cubed. So it's difference of squares minus cotangent cubed. And then, oh, I didn't leave enough space for this thing. And then, yeah.
Okay, does that work?
Yes.
Notice that over here everything's squared. So we got to keep going. This is now difference of cubes. Factor that.
Oh man. Okay. So it's different, so you'd subtract it. So it's cosecant x minus cotangent x. And then cosecant squared minus plus cosecant times x times cotangent x.
I'm going to leave out the x just because there's so much to write. I don't need extra stuff, and as long as it's one variable, I'm good. Okay? So that is that factored. Now let's factor the sum of cubes. We know what the sum of cubes is too. You can't factor the sum of squares, but you can factor sum of cubes.
Yeah. So cosecant plus the cotangent cubed, or squared. No, just regular because it's little cubes. And then you got your cosecant cubed minus squared minus the cosecant. Oh man, times the cotangent.
Mm-hmm. I think it's that. Check my math, but I believe that that's what we end up with, is the 4 factors.
Yes.
Okay. Now, if I multiply this factor times that factor, what do I get?
1?
Yes. You get cosecant squared minus cotangent squared, which is 1. In other words, I can erase that and erase that. And now my left side has become these 3 terms times those 3 terms. Which is not helpful.
You know, we have a quiz on this tomorrow, and nobody in my class knows what we're doing, really.
Well, I know what we're doing, but I couldn't solve this first go around, and I'm not sure I can solve it now. When I multiply these two together, I get a cosecant to the 4th. Let's see, can I reduce anything? Cosecant squared plus cotangent squared, unfortunately, is not equal to anything. Let's see. Cotangent squared plus 1 equals cosecant squared, which makes cosecant squared plus cotangent squared not anything. So how, when you multiply that by that, do you get this? Well, let's multiply it, see what we get. Cosecant to the 4th minus cosecant cubed cotangent plus cosecant squared cotangent squared. Okay, and now let's do the second term times each term, plus cosecant cubed cotangent minus cosecant squared cotangent squared plus cosecant cotangent cubed. Finally, one more line for the third term. You see what I'm doing here, right?
Yeah.
I'm not sure it's going to lead anywhere, but hopefully maybe everything will cancel out. Let's see. The third term is cotangent squared cosecant squared plus cosecant minus cosecant cotangent cubed plus cotangent to the 4th. Now let's see, do I have anything that cancels? Yeah, I got a minus cosecant cubed cotangent and a plus, those cancel. I got a plus that and a minus that, those cancel. I got a plus that and a minus that, those cancel. And I end up with cosecant to the 4th plus cotangent squared cosecant squared plus cotangent to the 4th. Now, how does that equal that? I got a cosecant.
You get a problem where they won't make sense?
That's what I say. I've never seen one. I've never seen one. I can't even factor this. Can I? No, that's not cotangent plus, that's not cosecant squared plus cotangent squared. Ah. Quite certain I have not made a mistake on the left side. Now, hold on a second. Aha! Let's keep going here. Cosecant to the fourth plus, well, cotangent squared is, or rather cosecant squared is 1 plus cotangent squared. Cotangent squared plus 1 is the identity for cosecant squared. We might be getting somewhere here. So now that's cotangent to the fourth plus cotangent squared. I have a cosecant to the fourth plus a cotangent to the fourth. So now I have that. So now I have two cotangents to the fourth. So I have cosecant to the fourth plus 2 cotangents to the fourth plus a cotan squared.
You don't have like a 1 or anything to make an identity out of. Right?
Well, that's 2 straight half-hour sessions, and I've tackled this problem from 3 different ways, and I cannot get it to make it equal to that. It's probably because I need to do something with these fourths, and I don't know what to do with them. Cosecant to the fourth is cosecant squared times cosecant squared. I don't know. Sarah, I don't know how to solve this problem. I got a feeling that it probably is an identity, just because I've never seen them give anybody one that was not. But somewhere along the line, I think at this step here, when I got this is equal to this, the solution lies in that. I'm just not sure how. So I guess I'll have to leave you at that.
Okay.
Okay? There's probably some identity here I'm not seeing. The problem is cosecant plus cotangent is not an identity. Is that even equal to 1? Let's see. Cosecant or cotangent squared plus 1 equals cosecant squared. So cosecant squared plus cotangent squared, I would be equal to 2 cotangent squared plus 1. Ah, I'm seeing it now. In other words, somehow we have to get 3 cosecant squareds. If I multiply this identity by 3, I get 3 cosecant squareds. Well, the solution is going to lie along that line. I can tell you that right now. I know we're out of time and I got to let you go. But that's probably where I'm going wrong, is convert that cosecant squared plus cotangent squared into something like this. I don't know. Not very often I find a trig identity that I cannot verify, but this is one. This one is giving me fits.
Alright, I'll ask my teacher.
Alright. I will talk to you next Tuesday, Sarah.
Alright, thank you.
Alright, bye-bye.